Good afternoon, everyone. So today we are looking at the topic oxidation and reduction reaction. At the end of this class, you should be able to explain oxidation and reduction in terms of electron transfer. You should be able to identify oxidizing and reducing agents in a redox reaction. You should be able to justify why a chemical equation is redox based on changes in the oxidation number. Ever wondered why iron rusts, why fruits decay, why battery die? That's because all these substances that I have mentioned are undergoing a chemical reaction, which is called the oxidation and reduction reaction. Now you can look at oxidation and reduction reaction as atoms trading electrons, just like friends swapping gifts. So you might be wondering, what is oxidation? Oxidation is the loss of electron by an atom, ion, or a molecule. When a substance loses electron, it becomes positively charged. Yes. So let me write an equation. Let's look at zinc. Zinc periodic table. Zinc can lose 2 electrons from its orbital, and it will become zinc 2+. Here, because zinc has lost 2 electrons, we can say it has been oxidized, right? And here we are looking at zinc from an atom becoming an ion. Now, what is reduction? Reduction is the gain of electrons by an atom, ion, or a molecule. So when a substance gains an electron, we can say it has been reduced. So let's take an example of an equation. We can say copper 2+, right? Gains 2 electrons, and we have what? The copper atom. So here copper is gaining back the lost electron to become copper atom. For these 2 reactions, we can say that one is undergoing oxidation because it's losing electron, and one is undergoing reduction because it's gaining electron. Now remember that you can use this oil rig to always remember the definition of oxidation and reduction. Oxidation, which means loss of electrons, while reduction is the gain of electron. So oil rig. So what is redox? You might have noticed that when I was reading out the learning objective, I had mentioned redox. So redox is a short form of oxidation reduction reaction. So when oxidation and reduction happen at the same time, we call it redox reaction. So from the equations I've written earlier, where we have zinc and copper 2 ion undergoing oxidation and reduction respectively, we can say that since zinc lost 2 electrons, it has been oxidized, and copper 2 ion gains 2 electrons, so we can say it has been reduced. Now this equation can be illustrated using a simple experiment. So when you have copper 2 sulfate is bluish in color, so when you add a piece of zinc into a beaker containing the copper 2 sulfate, because a reaction occurred, you are going to have a deposit of copper which is looking like a reddish brown solid on the surface of the zinc. Now this reaction is also possible because zinc is above copper in the reactivity series. So reducing and oxidizing agent. The reducing agent is the substance that donates electrons, right? So now if we look at the reaction previously, we had noticed that what zinc lost 2 electrons, so that means it's donating electron. One thing you need to also understand is that in redox reaction, as one substance is losing electron, there should be another substance was gaining the lost electron. So that means we can say this process is complementary. So zinc lost 2 electrons, which was accepted by the copper 2 ion. So this reaction is here. That's the combined ionic equation. So from this reaction, we can actually say that zinc is the reducing agent because it donates electron to copper. So we can say zinc is the reducing agent. Also note that the reducing agent itself undergoes oxidation, right? And we have what? Copper 2 ions accepting the lost electron, and we can say it is the what? Oxidizing agent. So you can say reducing agent is the substance that donates the electron in a chemical reaction, while oxidizing agent is the substance that accepts electron. So what are the rules for identifying if a reaction is actually a redox reaction or it's not? Remember that we have different reactions in chemistry. Not all reactions are redox. Some might be neutralizations, some might just be thermal decomposition. So the first thing, to help you to understand if a reaction is redox or not, you can just use the words oxidation number. Remember these rules, that elements in their free states have their oxidation state as being 0. For ions, oxidation number equals the charge on the word ion. Oxygen is usually -2 in all its compounds except the peroxides. Hydrogen is +1, and the sum of the oxidation number in a compound equals 0. But for polyatomic ions, the oxidation number equals the charge on the ion. So how do I know? Simply note that if a substance has its oxidation number increased, so that means that substance is undergoing oxidation. And if a substance has its oxidation number decreased, that substance is undergoing reduction. So let's take, for instance, Mg plus O2 produces MgO. Let's balance up the reaction. Oxygen is 2 here, so we are going to add 2 to the product side, and that changes the number of atoms for magnesium. So we are going to add 2 to this part. So in this reaction, we have magnesium reacting with oxygen to give us magnesium oxide. So following the rule, the oxidation state of magnesium here is 0. The oxidation state of oxygen here is also 0 because these elements are in their free state. Now the oxidation number of magnesium here is +2, and that of oxygen is -2. Now looking at this reaction, magnesium has its oxidation number changing from 0 to +2. That's an increase. So we can say magnesium has been oxidized. While oxygen has its oxidation number decreasing to -2. So oxygen has been reduced. So this tells us one thing, that this reaction is actually what? Redox. So knowing if a reaction is redox or not, quickly calculate the what? Oxidation number of the species involved in the chemical reaction. So evaluation, I would like you to answer this question, give it a try, and let me know in the comment section if you have any difficulty answering this question or not. Thank you for watching.